Okay, so you're here because you want to improve on your grade, and I'm here to help you with that. So we're going to walk through these questions together. I'm not going to walk you all the way to the answer. I'm going to show you some of the steps and tell you how to finish the problem, but then you need to try to finish it on your own. And if you're having trouble with it, you can always bring it to tutoring. So let's take a look at this first question. It says, Pam is playing with red and black marbles. The number of red marbles she has is 3 more than twice the number of black marbles she has. She has 42 marbles in all. How many red marbles does Pam have? Okay, so let's talk about our variables. Okay, so I'm going to choose R. It's going to be my number of red marbles. And then I can say B is my number of black marbles. Okay, so now I need to be able to write two equations so I can relate my red and black marbles. The first one I'm going to take a look at is this. The number of red marbles she has is, okay, so the number of red marbles is, that's my keyword for starting that. Red is. So the number of red marbles here are, is, that means equals. 3 more, that means to add 3 somewhere along the way. 3 more than twice the number of black. Twice the number of black is 2 times the number of black. I write that by saying 2b. So the number of red is 2b plus 3. 3 more than twice the number of black marbles she has. That's my first equation. The second one says she has 42 marbles in all. Okay, so altogether she has 42 marbles. If I want to write an equation to represent all together, well, that's the number of red marbles she has plus the number of black marbles she has. That has to equal to 42. Alright, let's take a look at this next step. I have two equations. One of them I have R solved for. I have R is equal to 2b plus 3, okay? And then the second equation, well, I see an R here. If R is equal to 2b plus 3, I can easily replace it with 2b plus 3. I can replace my R with 2b plus 3. So let's try that. I'm going to replace this R inside this box with 2b plus 3. So I have 2b plus 3 plus b is equal to 42. There's nothing to distribute, so let's just get rid of those parentheses. 2b plus 3 plus b is equal to 42. Let's combine like terms. 3b plus 3, because I have 2b and b, that's 3b plus, and then bring down your 3. 3b plus 3 is equal to 42. Minus 3 on both sides. 3b is equal to 39. Let's divide by 3. And b is equal to 13. Now at this point, I know a lot of you went and circled 13. 13 is not the correct answer. If I go back and read my question, it's asking for the number of red marbles. I found the number of black marbles. I found that there's 13 black marbles. So now if you want to finish this problem, go back and go see if you can figure out how to find the number of black marbles once you have the number, see how you can find the number of red marbles once you have the number of black marbles, which we have. We said there's going to be 13 black marbles. See if you can find the number of red marbles. Question 2 says, a system of equations is shown below. Equation A is 5x plus 9y equals to 12, and equation B is 4x minus 3y is equal to 8. Which method eliminates one of the variables? Okay, let's try it this way. So I have 5x plus 9y is equal to 12, and then 4x minus 3y is equal to 8. So they give you a bunch of choices. This is equation A and this is equation B. That's bad. Okay. Choice A says multiply equation A by 4. So they want me to multiply this one by 4 and then multiply equation B by 5. We did learn this. We did say, yeah, bring the variable up and then, bring the coefficient up and bring this coefficient down. But the problem is if I do it this way, I'm going to get positive coefficients on my top equation and my bottom equation. Remember, we need opposite coefficients to eliminate. So clearly it can't be answer choice A. Okay, so from here you're going to try the other ones and see which one gives us the right answer, all right? And If you have time, I would even go ahead and multiply it out and make sure that it eliminates. Since you're doing corrections, you do have time to check that, so please do that. Question 3. What is the solution of the following system of equations? 2x plus 3y is equal to 12. I always like to rewrite my problems, just so it just helps me to understand what I'm even doing. So 2x plus 3y is equal to 12, and the other one says x equals to 1/2 y minus 6. We learned several different ways to solve systems. This one clearly tells me I should solve by substitution. How do I know that? Well, one of my equations has x solved for, right? Usually we have y solved for, but it doesn't really make a difference. So what I'm going to do here is I'm going to box what x is equal to. X is equal to 1/2 y minus 6. Now let's go back to the other equation. So in this case, our first equation, and box where we see x. I see it right here. Now, I'm going to replace this x inside this box with what it's equal to. So I'm going to have 2. And remember, we want to use parentheses. Inside my box, I have 1/2 y minus 6. And then outside the box, I have plus 3y is equal to 12. Okay, it's very important you guys see why we're replacing this x with 1/2 y minus 6. Okay, next step is to distribute. So 2 times 1/2 y, if you go ahead and plug that into your calculator, 2 times 1/2 just gives you 1. So I have 1y. And now don't forget, you need to distribute to everything. So 2 times negative 6, that gives you negative 12. And then plus 3y equals to 12. Okay, next step, combine like terms. I have 1y and 3y, that gives me 4y. There's nothing to combine the negative 12 with, so let's just bring that down. Okay, so I'm almost done. Let's add 12 to both sides. This is just solving the algebraic equation now. Your 12's cancel. 4y is equal to 24. Next, divide by 4. Y is equal to 6. Okay, so once I know y is equal to 6, I can look at my choices and say, well, obviously that means it can't be C, because C says y is equal to 0, and it can't be D, because D says y is equal to 3. Your job now is to figure out what is x. Okay, to find out what your x is, go ahead and take one of these equations, plug in your y value, and see what you get for x. Question 4. Which ordered pair is the solution of the following system of equations? Again, I just really like to write everything out over again. So 3x plus 2y is equal to 4. And then the other one is negative 2x plus 2y is equal to 24. Several ways you can do this. I'm going to do it the way that works every single time, but you guys can always try to eliminate y first, and if you're up for that challenge, go ahead and try that. I'm going to try to eliminate my x first. To do that, I definitely need to multiply. I need opposite coefficients. Okay, so there's a 2 on the bottom. I'm going to multiply by 2 on top, and a 3 on top, so I'm going to multiply the bottom equation by 3. Now I need to ask myself, do I need any negatives? The answer is no. I already have a negative on one of my equations, so I don't need to make any of them negative. So let's go ahead and multiply. I get 6x. 2 times 2y, that's going to be positive 4y. And then 2 times 4, that's going to equal to 8. And then on the other side, 3 times negative 2x, negative 6x. 3 times 2y, that's going to be plus 6y. 3 times 24. That will give you, let's see, 1272. All right, let's try to eliminate. So 6x and negative 6x, that cancels out. 4y and 6y. Let's combine that. I get 10y. 8 and 72. If I add that together, I will get 80. Divide by 10. I get y is equal to 8. So now from this point, very clearly, I'm not going to circle it because it's up to you. Which one of your answer choices has a y value of 8? And if you're really not sure, go ahead and see if you can solve for your x and then get to your final answer. But just from this alone, I can already tell which answer choice is the good one. Question 5. What is the solution to 2h plus 8 is greater than 3h minus 6? So I'm going to do it here. So 2h plus 8 is greater than 3h minus 6. So this is a lot like solving a regular equation. The only difference is that I have an inequality symbol. But the concept is the same. I want to get all my letters to one side and I want to get my number to the other side. I'm going to choose to have my h on this side and I want my number on this side. Okay, so if I want to do that, the first thing I'm going to do is to minus 3h from both sides. It's on the wrong side. So if I subtract 3h from both sides, it cancels here. 2h minus 3h, plug that into your calculator. Don't try to do it in your head. 2 minus 3, that gives you negative 1h. So I have negative 1h plus 8 is greater than negative 6. Next, I want to subtract 8 from both sides. That's on the wrong side, right? I said this side is only for h's. Okay, this cancels out. I get negative 1h is greater than 14, negative 14. Okay, and last step is to divide by negative 1. Now, there's a very, very, very important rule when I divide by a negative. Anytime you divide by a negative, your inequality symbol must flip, okay? So you work out that last step. Just remember, your inequality symbol has to flip anytime you divide by a negative. Question 6. Jordan works for a landscape company during his summer vacation. He is paid $12 per hour for mowing lawns and $14 per hour for planting gardens. He can work a maximum of 40 hours per week and would like to earn at least $250 this week. If M represents the number of hours mowing lawns and G represents the number of hours planting gardens, which system of inequalities could be used to represent the given conditions? Remember, we talk about this all the time. Money must go with money. So let's go ahead and circle all our money values. $12, $14, and $250. So when I am creating this inequality, at least my first one, all of these things need to go on the same sentence, the same inequality. Well, $12 goes with mowing lawns, which we said is represented by M. So that goes with 12M. So I got 12M. The next part, $14 for planting gardens. So that has to go with G, right? Because planting gardens is represented by G. So plus 14G. And I know that has to do with 250. Now the key word here is at least. At least. So let's think about a situation that you are in. If you must be at least 21 years old to buy alcohol, think about how old you must be in order to be able to purchase alcohol. Can you be 18? No, because you need to be at least 21. So that means you need to be greater than or equal to. So at least means greater than or equal to. All right, and now the next equation, he can work a maximum of 40 hours per week. So M, hours of mowing lawns, plus G hours, planting gardens, a maximum of 40 hours per week. So it has to do with 40, maximum. Okay, so let's say the elevator has a maximum weight of 500 pounds. So at a maximum weight of 500 pounds, can you hold 600 pounds? Absolutely not. The elevator will break apart. Can you hold 400 pounds? Yeah, you can. Okay, so we want everything that's less than, when we're talking about maximum, we want everything that's less than or equal to that number. So less than or equal to 40. Now, all you have to do is go back and see which one of your answer choices matches what we wrote here. Question 7. A system of equations is graphed on the set of axes below. The solution of this system is, and they give you a bunch of choices. I'm a little frustrated because a lot of you were asking, I don't see the shading. There is no shading. This is a system of equations, okay? System of equations does not have any shading. That's inequalities. Even if you were stuck on how to do this problem, you should have gone through and plotted all these points. So let's see, 4, 2, that means, and this was a very common mistake also, your first coordinate is your x. That means how far you're going this way, okay, left and right. Your second coordinate is how far you're going up and down. So for 2, that means 4 on your x and 2 on your y. So 1, 2, 3, 4, and then up 2. Okay, this is where coordinate A is. Sorry, answer choice A. Let's see if I can do the other ones. Okay, so I did that in blue. 8, 0. So that means go across 8, but we're not going anywhere up and down. So 1, 2, 3, 4, 5, 6, 7, 8. This is answer choice B. Answer choice C says 2, 4. 1, 2, 1, 2, 3, 4. So answer choice C is right here. And last but not least, answer choice D says 0, 4. So 0, don't go across anywhere, and then let's just go up 4. Answer choice D is right here. Now, this is a system of equations, okay? A system of equations, the solution to a system of equations is where these two lines intersect. So go ahead, take a look at the 4 points we plotted. Which point shows the intersection of the two lines? That's going to be your answer. Question 8. Determine the number of solutions the system of equations has below. Okay, so says y equals to negative x plus 15 and y equals to negative x plus 25. There are several different ways we could have solved this, but let's just talk about what it means to have these solutions, okay, in terms of what it looks like on a graph. So to have one solution is when we have one intersection. To have two solutions, that's not even possible in the system of equations. Okay, let's cross this out right away. We never talked about two solutions. Infinite solutions are if the lines are exactly the same. So we have the same line. And no solutions are if we have parallel lines. If you are savvy with your calculator, you can go ahead and type both of these into y equals on your calculator and graph it and see what it looks like. Do I have one intersection? Are they the same line or are they parallel lines? Now, the other way to do this is algebraically, okay? So you see how I have y is equal to negative x plus 15 and y is also equal to negative x plus 25? Well, that means I can just set them to equal to each other, much like the substitution method. If y is equal to negative x plus 15, I can just replace this y with what's in the box, okay? So I'm going to have negative x plus 15 is equal to negative x plus 25. All right, if we're trying to solve this, let's bring all our x's to this side and bring all our numbers to this side. So add x to both sides. Well, that cancels out. I get 15 is equal to 25. I know that's not true. 15 is not equal to 25. So we talked about what happens when we get something like this, okay? If you don't remember, go ahead and look back in your notes. What does it mean in terms of the number of solutions when I get something that is untrue? Question 9. We're going to try to use that same strategy that we used for question 7, which is plot all of these points first, okay? 9 says which order pairs in the solution set of the system of inequalities shown in the graph below. Again, your first coordinate is your x, your second coordinate is your y. So let's try to plot this one. A is negative 2, negative 4. So negative 2, 1, 2, 3, 4. Negative 2, negative 4. That's A. Please don't stop until you've plotted all of them. I know some of you guys feel like you got the answer, so then you stop what you're doing. But plot all of them and see really which one makes the most sense. Because if we don't do all of them, that's when we start making careless mistakes. So negative 2, negative 1. That's right here. And this is what I mean. A lot of people chose B because they see, oh, that's the intersection. But we need to look at this line and we see that it's a dashed line. We talked about in class that dashed lines are not part of the solution. Cannot have a dashed line. Okay, so I already told you that B is not the answer. So let's take a look at C now. Negative 2, 2. Negative 2, 2. This is C. And then we can take a look at D. D is at 2, negative 2. So 2, negative 2. Okay, so we have all of these points plotted. Just recall that The solution to an inequalities is where the shading overlaps, meaning it's been shaded twice, okay? You got double shading. Question 10, which inequality is represented by the accompanying diagram? Okay, several things I notice. It's a dashed line. That's the first thing I notice. I think that's the biggest giveaway for me. Dashed line means it's either going to be less than or greater than, okay? We don't want these, okay? Because these create solid lines. So I know it has to be one of these answer choices. So go ahead right now, cross out the ones that don't fit. I'm not going to do it on my paper. You're just going to do it on your own. So cross out the ones that don't fit. And now, from this line, I notice that I'm shading below my line. Do you guys see that shading? It's below your line. We talked about this. Shading below your line means you're either using less than or you're using less than or equal to, okay? So the greater than does not work and the greater than or equal to does not work. So go ahead again. Cross out the answers that do not make sense, okay? I'm not going to do it on my paper. You should be doing it on your own paper. This should also be written on your paper if you got this wrong. You need to know this. Your dashed line does not have this equal to underneath the inequality symbol. And if you're shading below, you're going to be using the less than symbols. If you're shading above, you're going to be using the greater than symbols. Remember, less than. Yes, this is an L. And the less than symbol kind of looks like a slanted L, okay? That's how you can remember the difference between less than and greater than. Question 9, my favorite. 9 says, on the set of axes, graph the following system of inequalities and label the solution as. Give you some time right now. Go get 2 colored pens. I got an assortment right here. I'm going to choose my favorite colors. This teal looking color and this coral looking color. You do not have colored pens. Get some right now before we do this problem. Okay, I'm ready. So let's take a look at this first inequality. I got y is greater than or equal to negative x plus 2. Y has already been solved for, so I can graph this right away. This is your b, or your beginning point, and then your m is going to be negative 1, and I want to put that over 1. So that's your m. That tells you your movement. That tells you to go down 1 because of the negative 1, and then to the right 1. So I'm starting at 2, and then I'm going down 1 to the right 1. So let's start at positive 2, down 1 to the right 1, all the way through. And, ooh, I messed up. It's okay. To ensure our line is as beautiful as it can possibly be, I want to draw the dots on this side. So we want to do the complete opposite. The complete opposite of going down 1 is going to be up 1. And then to the right 1 is to the left 1. So let's finish this. Okay, let's see. I need a straight edge because I need to connect this. I should have been prepared. Go grab a straight edge if you don't have one right now. All right, let's connect this. What type of line should I connect this with? Well, it's a greater than or equal to, so this means solid line, please. Connect this with a solid line. And last thing I need to do for this, well, let's label it actually, okay? I know we haven't been doing that in class, but it'll help us. Also, my orange one, I did this all in orange, is going to be this equation, this inequality up here. Last thing I need to do, because it is an inequality, is to shade. The symbol, after I'm done solving, says greater than or equal to. So that means to shade above. So let's pick a point, any random point, and draw that arrow upwards. So when I'm shading, I need to cover this arrow, which means I'm going to be shading this side of my graph. Again, please don't make crazy shades, right? Just nice, gentle lines. Okay, that's that. Now, let's take a look at this second one. The second inequality, unfortunately, is not solved for, so we need to solve for it. 5x minus 2y is greater than 8. Minus 5x from both sides. Okay, so this side I'm left with negative 2y is greater than. We cannot combine these because this one has an x, negative 5 has an x, but 8 does not. So we can't combine them, just rewrite it. Negative 5x plus 8. Next step, y is still not by itself. There's a negative 2 there, so I need to divide by negative 2. Now remember that very important inequality rule. When you divide by a negative, you must flip your symbol. So why? Flip our symbol because we're dividing by a negative. It was greater than, it now becomes less than. Negative 5 divided by negative 2, well, if you put that into your calculator and change it back into a fraction, that's just 5 over 2. X, and then positive 8 divided by negative 2. See if you can get that. Negative 4. Okay, so now I have my beginning point, your B, and I have my movement. Start at negative 4. My movement, since it's a positive 5, go up 5 and to the right 2. So let's see if we can do that. Start at negative 4. 1, 2, 3, 4. Go up 5 to the right 2. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4. Oops, I can't. I'm off the graph. So let's go the other direction. Go down 5 to the left 2. 1, 2, 3, 4, 5. 1, 2. And again, I don't have any more room to go down 5. So I have 4 dots. We can connect them. Let's think about what type of line we need to use. If this one had a equal to and it was solid, it means this one must be dashed. Right? We don't have that equal to symbol. So we're going to connect this with a dashed line. Be careful what you're doing with this with pen, because you don't want to accidentally make it a solid, then you would have messed up and we can't erase that. Okay, draw our arrows. And last but not least, shading. When we are shading, we are taking a look at the one that we have solved for, okay? Not at the original. We're taking a look at the one we've solved for. So, less than, that means I'm shading below. So let's pick a point. Let's pick this one right here. And let's below, I'm going to draw the arrow going down and try to ignore the orange lines. I know it's difficult. Try to ignore it. I'm just looking at this green line. I see this half of my graph, and then I also see this half of my graph. We want to think about which half we're shading. If I shade this half of my graph, I would not be covering the arrow. If I shade this half of my graph, I would be covering the half of the arrow. So I'm going to be shading this half of my graph. Ooh, you see how beautiful that looks when we use colored pens? And it makes it so much more neat and organized too. Label the solution S. Where's my solution? Oh, it must be here, where the double shading occurs, where the overlap shading occurs. So let's just draw a giant S there. Okay. Make it nice and pretty, up to you. I like to. And one more part. State the coordinates of one point that satisfies y is greater than or equal to negative x plus 2. Ooh, that's our orange. This is where it helps to have done it in color. So I wanted to work for the orange, but not for the green. So basically what this is saying, if you had done it in color, is I wanted to be in the part where the orange is shaded, but not where the green is shaded. The best way to do this, again, is just to pick a point, any point that you like. Any point that's in the orange but not in the green. So I like this point right here. And then you can give the coordinate for that point. I'm not going to do it here. You do that on your own. Question 10. Solve the following systems of equations algebraically. 4x plus 2y is equal to 4 and 3x plus 3y is equal to 9. Only an algebraic solution can receive full credit. Okay, so 4x plus 2y is equal to 4. And 3x plus 3y is equal to 9. I think most of us realize we have to use elimination. Problem is just figuring out what to multiply by. So I'm going to try to eliminate my x. I see that there's a 4 next to my x on top here, so I'm just going to bring it down. And I see there's a 3 on the second equation, so I'm going to bring that up. Okay, and again, we want opposite coefficients, so one of these must be negative. I will choose the first one to be negative. Entirely up to you. Okay, so let's now multiply and distribute. Negative 3 times 4. Oops, that's okay. Negative 3 times 4, that gives you negative 12x. Negative 3 times 2y, that gives you negative 6x. Negative 3 times 4, that gives you negative 12. And now on the flip side, 4 times 3x, that gives you 12x. 4 times 3y, that gives you plus 12y. And 4 times 9, that gives you 36. Okay, now I'm ready. So, good. My x's get canceled. Negative 6x. Oh, I must have messed up. Oh, that was a y. My bad, guys. Okay, so that was a y. I'm glad I caught that. Negative 6y and positive 12y, that gives you 6y. And then negative 12 and 36, that gives you 24. Let's divide by 6. Y is equal to 4. Okay, good. Got one of them, right? We need the other one. So remember, our solution is always a coordinate point. I got the 4. If you want to solve for the other one, you need to plug it back into the original equation, whichever one you like. Everything's positive. All the numbers look pretty easy to work with, so it doesn't really matter. I'm going to choose this first one. 4x plus 2y is equal to 4. My y is equal to 4, so that's what you're replacing. 4x plus 2 times 4 is equal to 4. You work through the rest of the solution from here. I believe in you. Question 11. For a class picnic, 2 teachers went to the same store to purchase drinks. One teacher purchased 18 juice boxes and 32 bottles of water and spent $19.92. The other teacher, so let's write this. The other teacher purchased 14 juice boxes and 26 bottles of water and spent $15.76. Write a system of equations to represent the cost of a juice box J and a bottle of water W. So first, what I underlined in red, 18 juice boxes, okay, that's 18J, and 32 bottles of water. Oh, so plus 32 bottles of water, spent $19.92 equals to $19.92. Second part, 14 juice boxes, so 14J plus 26 bottles of water equals to, well, this person spent $15.76, so $15.76. That's all you have to do for that first part. Next, Kara said that the juice boxes might have cost 52 cents each and that the bottles of water might have cost 33 cents each. Use your system of equations to justify that Kara's prices are not possible. So already I'm telling you she's wrong. I just need you to show me why. Okay, well, let's take a look at this first equation we wrote. 18J plus 32W is equal to 1992. Well, Kara says that juice boxes were 52 cents. So instead of writing J, I'm going to replace that with 52 cents. As a decimal, that's 0.52. And then she said water bottles cost 33 cents. That's 0.33 equals to 1992. Okay? Go ahead, let's plug this into our calculator. 18 times 0.52. That gives you 936. 32 times 33 cents. That's going to give you 1056. And that's equal to 1992. Well, in fact, if I add it, I do get 1992 equals to 1992. So this first equation makes sense. But I know it's not possible, which means something must be wrong with the second equation, okay? So 14J plus 26W equals to 1576. So use her prices, plug in for the juice, plug in for the water, and prove that it is not possible. You're going to do that on your own. The last one is something you guys are very good at. It's just the numbers were very big, so that might have been confusing. Solve your system of equations to determine the actual cost in dollars of each juice box and each bottle of water. So let's rewrite it. 18J plus 32W equals to 1992. And 14J plus 26W is equal to 1576. So all I did was rewrite my two equations from up here down here, okay? We're going to solve this by elimination. So there's an 18 on top. I'm going to bring it to the bottom. So 14 on the bottom, I'm going to bring it to the top. Since they're both positive, I need one of them to be negative. I will choose this first one to be negative. All right, let's multiply out. I get negative 252 juice, or J, minus 48W equals to negative 278.88. Okay, so you're multiplying every single thing by 14. And next step, 18 times 14, that gives you positive 252J. 18 times 26W, that gives you plus 468W. And 18 times 15.76, that gives you positive 283.68. Okay, let's do this. Eliminate the J's. Negative 488W plus 468W, so now we're left with 20W, is equal to negative 278.88 plus 283.68 is equal to 4.8. Now if I want to solve for W, divide by 20 on both sides. And I get W is equal to 0.24. So if you want to solve for juice, take one of these equations, whichever one you like, and let's plug in W. So I'm going to take that first one. 18J plus 32W equals to 1992. Water was 24 cents, so I'm replacing water. 18J plus 32 times 0.24 equals to 1992. Simple algebraic equation, okay? You're gonna work through the rest of this on your own. There are two parking garages in Beacon Falls. Garage A charges $5 parking fee and each hour costs $3, which can be modeled by the equation 3x plus 5, where x is the number of hours. Garage B charges $3.25 per hour to park and no parking fee. So part A says write an equation to model the cost of parking for a total of X hours in garage B. We're going to use the equation they gave us in A to help us with B. So the equation they gave us is y equals to 3x plus 5. Well, what did this 3 stand for? This 3 stood for each hour. All right, because it was $3 for each hour. What did the 5 stand for? The 5 stands for the parking fee. So now I want to rewrite you can't see that. I want to write that second equation for garage B. So I have y equals, well, okay, so the 3 was how much it costs per hour. If we take a look at garage B charges $3.25 per hour. So that's going to be 325x. And then the 5 is my parking fee. What's my parking fee in garage B? There is none. How do I write that there is no parking fee? Plus 0. You don't really need to write it since it's plus 0. So that was good. I have two equations now. Y equals to 3x plus 5 and y equals to 3.25x. You don't need the plus 0. Determine algebraically the number of hours when the cost of parking at both garages will be the same. Same. This is a key word for us, okay? Whenever we see the word same, mathematically, it means when they're going to be equal. So this is how much garage A charges and this is how much garage B charges. I want to know when they're going to be equal, so I need to make them equal to each other. I want to know when garage A is going to be equal to garage B. Garage A is going to be modeled by this, 3x plus 5. When is that equal to how much garage B charges? Garage B is 3.25x. See how simple it is now? We just have a very simple algebraic equation. You need to solve for x. Go ahead, work through this on your own. If you don't know how to do anything, bring it to tutoring. Nice job, guys. We made it all the way to the end.